confirm you're able to see my screen. Thank you. So I'm recording the session and I'm sharing my screen. So again, for those one who are joining us for the first time, you're welcome to join the group. So this is just a platform to exchange knowledge and learn from each other. So we've been having these sessions, maybe 2 times or 1 time a month, and we've covered 7 sessions so far. This is our 8th session, and I've been the trainer, Martin Indeche. I work for Nokia as an IPCO engineer. So today we are doing some hands-on lab. We are implementing service configuration and HoVPN architecture on Huawei routing devices. In our last session, we already discussed about the HoVPN solution and how the mobile services are deployed on the service provider network. So if you missed it, you can get the recording from our YouTube channel, Life Technologies, and just a request that if you are yet to subscribe, kindly find that subscribe button and click on it. So, do we have any question from the previous session? Any question from the team concerning our previous session before we dive deeper into our today's session? Maybe you went through the slides and you find some question or some issue that you require clarification. You can bring it up. We clarify it before we start our today's session. Or any comment? Okay, if there is no question, then we'll go straight to our today's topic. So I've mentioned that today we need the draw. Today we are discussing about service configuration and HoVPN architecture implementation. So in our last episode, we already discussed about the SRAN solution. So we will be deploying the SRAN solution. Remember the SRAN solution, we just have one hardware, and this hardware is able to support different technologies like 2G, 3G, 4G, 5G, and any other new technology that will be coming in. They should just be able to maybe do software upgrade or some kind of optimization, and then they should be able to support that new technology. So we just have a single connection from the BTS to the CSG that is at site. So that one we call it the SRAN, single run solution. So we have moved from the traditional solution where you had to plug in maybe 5 cables or 6 cables from the BTS, from the different BTS for different technologies to the CSG. So now we are just using one connection from the BTS to the CSG, and we configure all the services on that single connection. So this is the topology that we are using. You can see that I've used the HoVPN naming. Remember in HoVPN we have the NP, SP, and UPE, which in IPRAN just translates the RSG, the ASG, and the CSG. So we have 2 NPs that are connecting to the VPC. So this VPC will be the controller network. For example, the RNC, the BSC, and even the EPC, the Wolf Packet Core for technologies like 4G and 5G. So we have the switch will be connecting to the VPC, and then we have some networks that needs to be accessed from the BTS. So our end goal is to ensure that we have communication from the BTS to the controllers through our IPRAN network. So we have the 2 SPs, we have the 2 UPEs, just a small ring here, because you can see there is an interconnect between the 2 UPEs. So we are forming a ring. Remember, the ring topology is always the most common topology deployed on IPRAN network. And then we are deploying ISIS. So we'll be using access ISIS 10 and aggregation ISIS 100. You can see the different IP addresses that have been assigned. We have the point-to-point IPs. We have the service IPs, both on the controller side and also on the access side, the BTS side. We have these IP addresses that will be assigned for different technologies. So we simulate how to configure 2G, 3G, 4G, 5G, and O&M. The process is similar. Of course, you just need to ensure that when you are configuring a service, you are mapping it to the correct VPN instance or the VRF. And then we'll be deploying BGP. So remember, we are using the MP IBGP and we are building L3 VPN. So we need to deploy MPLS on this network. So from the UPE to the to the NPE will be our MPLS backbone. So we'll be deploying MPLS on this network. We will be configuring BGP peering sessions. So for the BGP, as discussed in our BGP design principles, you configure BGP to the ASGs, or the SPEs. So we have sessions to the two SPEs for redundancy. Same way, UPE2 will also be peering to the two SPEs. And then for SPEs, they establish also a redundant peering session to the NPEs. So once we have the BGP, we have MPLS, we have IGP, everything is ready. Now we move to the next stage of configuring services. So you have a BTS or you have a new site that is coming in. How do you configure the services so that they are up and you do the service test to ensure that you have end-to-end communication for the different services. For the communication from the NPE to the controllers, we are using OSPF. This is the protocol that is commonly used. You either go with the static routes, or many times I've seen OSPF being deployed in such scenarios. So we configure OSPF towards the controllers. And once we've done that, we test our connectivity and ensure that there is communication from the BTS to the controllers for different technologies. So same topology in ENSP. So this is the same topology, just I will be sharing this one also as it was requested in our last session. I will share the topology so that you can go ahead and do the network simulations from your end. Do we have any questions so far? Any question on the topology? Anything that we need to explain from the topology, maybe that is not clear?
Allô, Mathieu.
Yes, yes.
Bonjour.
Bonjour.
Hmm. Uh, please, I cannot see your screen. Huh?
You cannot see my screen?
Now it's okay. 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 Good.
Okay.
Uh, uh, um, right now you said between BTS and UP,
Yes.
we can use um, many links,
Yes.
but for now we are using only one. And
This, maybe let me just correct you.
uh,
Traditionally, we used to have different hardwares for different technologies, which we call the SRAT solution. But nowadays, we have the SRAN solution. So with the SRAN solution, this hardware should be able to support the different technologies. So we only need one single connection from the BTS to the UPE or the CSG. That will be enough to support all the different radio access technologies. Y-
correct. So
Yeah.
you mean we can use LAN cable or fiber, right?
Yes, yes. Many times, of course, it depends with the type of connection supported by the BTS. Because for the CSG, they can support both the Ethernet cable, the Cat5, Cat6, or they can use the fiber connection. And if you need maybe a capacity of 10G connection on this link, then you see you cannot use the Ethernet. You need to use the fiber for that higher capacity link.
Correct.
Yes, so you can use either the Ethernet, the Cat5, Cat6. If you use the Ethernet, you also need to ensure that at least it can negotiate 1G. If you use just maybe Cat5, you may find that you are operating at 100 meg and you'll have issues.
Okay. 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 Thanks.
Anyone else with a question before we move to the next stage?
Hello, Martin.
Yes, Jonas.
Yeah. Um, so I noticed on the VPC side, we'll be
Yes,
using OSPF for the PEC routing.
yes.
But how about the BTS side?
For the BTS side, many times they'll just configure default route pointing to the gateway that has been configured on the CSG. I've never seen a scenario where we configure routing protocol between the two, like a dynamic routing protocol. No, they will just configure static routing to any network that they need to access.
Oh, okay. Okay. Thank you.
Welcome. Anyone else with a question before we move to the next?
Hello, Martins.
Yes, yes.
I wanted to inquire the need why we use /29 from the BTS to the UP.
Yeah, I think the same question was asked in the group. Sorry. So you can use /30. You can use /31, depending on how the setup is. Sometimes on special occasions, you may require some extra IPs. So you will find that many times they use 29, but you can still go ahead and use 30 depending on what you expect. Maybe sometimes, maybe special requirement like you want to have redundant, maybe VRRP connection for the BTS, you see, you will need extra IPs. Or maybe you need to configure some kind of floating IPs, then you will need extra IPs from that block that you've assigned. So if you are sure that you only need two IPs, then no need to waste the IPs. You can go ahead and use
Okay.
/30 or /31.
Okay.
Yes.
Just this for the sake of redundancy then.
Yes, maybe you have some special
Are they
requirement.
usually public address?
No. Many times these one are private IP addresses. Remember, this is within the same network, so you will not use the public addresses. You use the private. Even for the point-to-point configuration, we normally use the private IP
Okay, that
addresses.
is 10 dollars.
Yeah. So we are not wasting public IPs.
Okay, thank you.
Hello,
Yes.
That's
Martins.
it.
Hello.
Yes.
What do you mean by this floating IP?
Hello.
Anyone who can respond to a floating IP? Anyone who have worked with floating IPs?
I guess it's on the BTS side anyway, but I know I've heard of it, but I've not really worked on it.
Routing IP is a virtual IP. Let's say that you connect the BTS to two UPE, then you want to build the redundancy. So you connect two links to the two UPE from the BTS, and those UPE will work as one router virtually, but logically they are separate in two. So what you need to do is to configure a floating IP which will float between the two UPE, so that in case of a failure on the first UPE, the traffic will automatically shift to the second IP without interruption.
Thank you for the clear explanation. Anyone else with the last question? Someone was unmuted before we move to the next slide.
Hello, Mr. Martin.
Yes.
How are you? I hope you fine and everyone in the session they are all fine.
Yes, we are doing great.
Okay. Uh, when you started about the explanation, I wanted just to find out on the site of the BTS,
Yes.
like the antennas, the tower. On the tower, we have all different technologies: 2G, 3G, 4G, or it's different towers with different technologies. What per tower, one technology. Per tower, one technology. Is that the way?
No, no, no. We have all these integrated into the same hardware. One tower has all the technologies. Because you see, you have the antennas up there. Those antennas are able to serve the different technologies on the same tower. Yes.
Okay, okay, okay,
Yes.
okay,
Okay.
okay.
Okay. Thank you.
So that means that per tower we have antennas for 2G, 3G, 4G for all the technologies. Huh?
Yes. Yes.
It's not like we have a tower for 2G, for 3G, not that way.
No. 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 No.
Okay, okay.
Okay.
Thank you.
You're welcome. Yes, Idris. Yes, Ahmed. Yes, you can proceed. I see some people raising their hands. Saravanan?
Hello, Mr. Martin. This is
Yes,
Nixon.
Nixon. Yes.
Yeah, my question there is between the CSG and
Yes.
the BTS.
Yes.
All of those 2G, 3G, 4G, 5G, O&M IPs. Are
Yes.
we going to configure them on a sub interface on the router end, or how do we go about it?
Yes, yes. We configure it on sub interfaces on the router end.
Okay, so the other question there is I believe on the BTS end, we're
Yes.
dealing with VLAN, right?
Yes.
So on the VLAN's end, we also do a sub interface attach, right?
No, no, no. You can configure the VLAN if interfaces, right? Okay, I haven't configured a BTS before, but what I believe is they should be supporting these different, like configuring configuring the VLAN if interfaces on their end. So they can go
Yes,
with, if
yes.
they support sub interfaces, they can also configure sub interfaces. If they don't support it, then they can configure the VLAN if interfaces.
Yes, I've done that before on the
Yeah,
BTS site.
yeah,
But what we normally do is we do sub interface on those end and in coming I mean based on the VLAN configured on the router's interface.
yes.
Oh, all right. Thank you.
You're welcome. Last question, last question, last question. Yes, Saravanan, we can't hear you. We can't hear you if you are speaking. Or is anyone able to hear him? I'm not able to hear from my end, but he's unmuted.
I'm not sure anybody's hearing him. Maybe he should be louder with it.
Okay, then let's wait for him to fix the issue, then we can come back. So to the next few slides. We start by the implementation steps. So for the implementation steps, we need to do some planning and data preparations. Remember, before you do any deployment, there is some preparation that you need to do. You need to prepare the data, you need to assign the IP address that we'll be using, the device name. So all that comes into the first step of planning and data preparation. Then the second step, we need to do some basic configurations on the UPs, SPs, and NPs. So the first, we do the system name, the interface IPs on these three devices. We also need to configure an IGP. So remember, we are using ISIS as the IGP. So we need to configure ISIS, enable it on the interfaces, and ensure that we have adjacent this app. We are able to reach the different networks configured on this MPLS backbone network. Then we also need to enable MPLS LDP on the UP's SPE. Remember, this is BGP MPLS VPN. So we need to configure MPLS and MPLS LDP for label distribution on the UP's, SPEs, and NPEs. Once we've done that, we need to configure the VRFs, virtual routing and forwarding instances, on the UPEs, SPEs, and NPEs. And then we need to establish MPI-BGP peer relationship between the UPs and SPs, and also between the SPs and the NPs, so that they are able to exchange the VPN routes. Once we've done that, we need to configure some static routes, some default static routes on the SPs. So the static routes, you will see them. I will explain once I'm at that stage. Then we need to configure SPEs to advertise default route to the UPEs. So this is where HoVPN comes in. We need to ensure that SPEs are advertising only default route towards the UPEs for the HoVPN solution. Once we've done that, we also need to configure the UPEs. So we configure the UPEs facing the BTS, the interface from the UPEs facing the BTS. So this is where we configure the sub interfaces, we bind the VPN instances, and we also indicate the VLAN and also the IP address, the gateway that we are configuring. We configure the VPC, which will be the controller for different technologies. We ensure that OSPF is up. We are able to learn the routes on the NPEs, and then finally we perform service tests. So these are just the general steps that we'll be following. So for the data preparation, this one we've already covered in our previous session, so it's just a recap. We start by the IP planning. So for IP planning, you need to have the loopback IPs, you need to have the point-to-point. Also, we are planning for the ISIS network entity. So remember, we are using ISIS, so you need to configure the network entities on the different nodes for different IGP processes. I know we all remember how to generate the network entity from the loopback IP. If you've forgotten about it, you can visit, you can review our previous sessions on this series. And then for the loopback IPs, these are the IP that we'll be using. Remember, loopback IPs have a very important role. One of it is we have used it to generate the network entity. We need to use it to configure the router ID, the MPLS, LSR ID. All these will be used as the loopback IP. And then the IGP process, I've already explained that we are using access, ISIS 10, aggregation, ISIS 100. Then we have the VRF data planning. So for the VRF data planning, of course, we have different VPN for different technologies. So we have 2G VPN, 3G VPN, 4G, 5G, O&M. These ones are just based on this lab. You can have your own, you can configure more, you can configure less, depending on how your network is designed. So remember, this is just an example. You can have one for signaling, you can have one for user plane. It's all fine. You just need to do as per your network setup. And then the route distinguisher. Remember, with VRFs, we have two important things that we need to configure. We have the RD and the route target. So the route distinguisher and the route targets. So for the route distinguisher, we are using type. Which type of route distinguisher is this? Anyone who remembers from our last session? We said we have two types. We have type 0, type 1, and type 2. Which one is this? The one that we are using currently in this setup. So we'll be using loopback IP : a random number. Which type of route distinguishers are these? Anyone from the audience?
Type 1.
Yes?
Type 1.
So yes, these are type 1 route distinguishers, which are always the most recommended one.
Sorry, I have a question.
Yes.
So the O&M, the O&M VPN, this one is for the management of the CSGs and the IPRAN nodes. What about the management of the services, 2G, the RAN node themselves, the node Bs?
Yes, it can
Or
still
in this?
go through the same O&M VPN.
Okay.
Yeah, but again, remember I mentioned that this one is just based on my design. You can still have more VRFs for different services.
Okay, so that means, but you use different subnet for,
Yes,
I
yes.
mean, okay, all right.
You use different subnet for different VPN instances. Then we have the route targets. So for the route targets, we are using the AS number. This is the AS number that we are using, 65008, and then we add a colon, then a random number. We are using both. So this is for both import and export direction. Next table explains how we are planning data for the BTS. So for the different technologies, we have the VLAN that will be used, 1000, 101, 102, 103, 104, and then the subnets and the gateway that will be configured on the CSG or the UPE. And then for BTS2, we have the same, the VLANs, the subnets, and the gateway to be configured on the UPE or the CSG. For the VPC, we also have the same. We have the VLANs, we have the subnet, and also the gateways to be configured on the switch. And that is it for the data planning. Do we have any question or any clarification?
Hello, Mr. Martin.
Yes.
Uh, I'm just saying, I just want to ask about the root distinguisher.
Yes.
Uh, I know that you already spoke about it. It was on station number 2, if I'm mistaken.
Session number 7.
Number 7, eh? Okay.
Yes.
Okay. So if we have this root distinguisher and we can have the same IP address, using the same IP address for all the service technology 2G, 3G, 4G, and we can differentiate them with the root distinguisher, put them different numbers. Is that okay, right?
Yes, yes.
And if I do this kind of design, the purpose is to save IP or to achieve what is the purpose, the benefit of doing that?
Of doing what exactly? Maybe you can.
To have the same IP for all the, using the same IP for all the technologies, and differentiate them based on root distinguisher.
Yeah, remember the essence of having the route distinguishers, of course, it's to make the routes unique. And once they are unique, because you see, this is just a symbol setup. But again, what if you have like many other customers who are depending on your service provider network and you are establishing L3 VPNs for them? So you see, you may not, a service provider network may have thousand or 100,000s of customers. So which means maybe even for the private IPs, you don't have enough of them. And you are just allowing them to use the same overlapping addressing space for them to carry their services.
Okay. Uh,
So it's just allowing the
okay.
use
So
of overlapping addressing space on our backbone network.
okay. So it means that if you don't have enough, uh, okay, on the BTS side, before first I carry on with this question, on the BTS side, between the BTS and the CSG, we have a private IP, right?
Yes. Even for the
And
point-to-point connection, even for the VPC, we are still using private IPs.
okay. So if I use the same IP to avoid overlapping for all the services, so the benefits of that, or the purpose, is to save IP addresses, or just to make it easy to troubleshoot, or maybe to remember the IP, or what is the purpose of behind it?
Using the same IP address.
Yeah, for all the service, 2G, 3G, 4G. To avoid overlapping, then I use different
Route
RD.
distinguishers, yes.
Yeah.
Yeah, if
So
you
the
don't, if
purpose,
you are a service provider who has a big customer base, then of course you have to consider that. It will help you to conserve the IP addresses because
okay,
yes, once you just need to ensure that your planning is very okay for the route distinguishers, for the RTs, they should be very okay so that you don't have any conflict in the network.
okay, okay then. Thank you.
So we are good. Anyone else with a question before we move to now the configuration stage? Okay, so for the configuration stage, I know we've already covered many of these configurations, many of these basic configurations. So we'll just be going through them as we configure. So the first step, we mentioned that we need to configure the system names, IP addresses on the UP, SP, and the NPEs. So the basic configuration include the sysname. Ensure you've configured a correct sysname depending on the company's convention. If it has specified that you need to give the site name, the site ID, and maybe the device type, or all those information should be included in the system name. For here, I'm just using NP01. And then for the interface configurations, you need to assign the correct IP addresses. So always recheck the IP addresses, ensure that you've configured the correct mask, you've configured the correct IP address, you've configured it on the correct interface. Once you are done with that, we are also configuring the loopback IP. So for the loopback IP, also you ensure that you've configured the correct loopback IP address on that interface because it will be used for multiple purposes on this network. So same has been done for the different devices. So I'll just go ahead and start doing the configurations as we verify and identify any issue that we could be having when doing the configurations. But if you have a question, you are allowed to ask the question as we continue with the configuration. So this is the setup in ENSP, and we are starting with NP1. So on NP1, I just need to do terminal monitor so that it doesn't interrupt us. And then I can do the configurations for NP1. That will be it. NP2. So I just used 6 devices. In a real network, definitely you have hundreds and thousands of devices that you need to configure. But of course, that network was not built on one day. It's built over time. But when you are bringing in a new device, you just need to know where you are connecting the new device and which parameters you need to configure for the new device. So this is for the SPE. So for the SPE, I will do the configurations. Anyone with a question is allowed to ask. If you don't understand any of these basic configuration, you can also ask. Yes. Someone is unmuted. You have a question, just proceed to ask. This is for SP02, same configuration, just interface, IPs, and the sysname. Then next, we configure the UPs. This was which SPE? Let me see. This was SPE2. Then we need to do the configurations for UPs. So for UPs, very simple configuration, the loopback IP and the point-to-point IP. We are using /31 IP addresses. So we start with UP1 and do terminal monitor. On a real networking device, you may not have to run the undo terminal monitor, but for the simulation tool, you need to disable it so that it doesn't bring the debug messages. Then finally for UP2. So for UP2, we finish the configurations. So once we've done these configurations, you can always go ahead and try to ping the point-to-point, ensure that they are okay. You can ping the point-to-point. You can run command like display IP interface brief. You should be able to see the IP addresses that I've configured. You can see the port status, physical up. The protocol is also up, and the assign IP addresses. You can also see the logical loopback 0 IP that we've configured. It's correctly configured. The status is up. On other devices, it should be the same case. Display IP interface brief. You will get the output for the different IP addresses that have been configured and the status. Any question on part 1 of our configuration? That's very simple, very straightforward. Yes?
Sir, as we have studied that on the customer side, if we have same IPs, so we make VRF and distinguish it. Sir, if we have 2G, 3G, and 4G and 5G services,
Yes.
and all have different private IPs, so is there any need of to make VRF? I am confused in this.
Just come again. Maybe I missed the question.
Sir, as we have studied that if on the customer side,
Yes.
we have same IPs, so we
Yes.
make VRF to differentiate it.
Yes.
What if we have 2G, 3G, and 4G on the customer side have different IPs? So in this case, we will make VRF or not?
It's still, you see, the aim of using VRF is to separate these services across the entire network, not just towards the customer, right? We need to separate these services across the entire network, and we need to isolate services for different customers. So that's why we are configuring the VPNs. And remember, we are also using the MPLS VPNs. So we will still need the VPNs even if we are using different IP addresses, because the aim is to separate the services, to isolate them from each other.
Okay, sir. So in
Yes.
this case, sir, we have 5 services. So we will make 5 VRF. Am I right, sir?
Yes. We make 5 VPNs. This is the ones that I'm showing on the screen. You see, we have 2G for 2G services, 3G for 3G services. We have 4G for 4G services, 5G for 5G services. On them, you can add DCN, you can have 4G signaling, you can have 5G signaling. All these can be created depending on the network setup.
Okay, sir. Thank you.
Okay, you're welcome.
So is it possible to now use, I think maybe that's part of the question people have been trying to ask. Is it
Yes.
possible to use the same, since we have different RD, is it possible to use the same, since we can have IP overlap, is it possible to use the same IP for 2G, 3G, 4G, since you already have RD distinguishing?
Yes.
So is
You
it
can
possible
go
to use
ahead
the
and use
same,
the same.
exactly the same private IP block? Okay.
Yes.
All right.
Because remember, they will be in different VRF routing tables. They will not mix.
Okay.
Yeah. Okay, the next step.
Omar,
Yes.
okay, I have a question here.
Yes.
Most of the time, when you configure the point-to-point IP address in Nokia, especially, just we create uh, an interface and we assign a port to that interface. Yeah.
In Nokia.
Yes.
Because Nokia and Huawei uses a different syntax during the configuration. So on
Yeah.
Nokia, you will find that you need to create the logical interface. That interface, maybe you give it interface to P1 or to what, you give it some kind of a naming, and then you need now to bind the ports and the VLAN under that logical interface. Yes.
Yeah, I understand that. But the problem that I cannot understand here is that after we're creating the logical interface, we
Yes.
assign IP address and we assign the port and VLAN. for point-to-point configuration.
No,
For
for the
example, we
yes,
yeah,
just finish.
yeah, I am working with Nokia subcontractor, so just I come across this issue and I cannot understand what does it mean. Just instead of tagging the port to the logical interface, we
Yes,
tag also the VLAN for the
yes, yes,
connection.
yes.
Was I don't understand this.
Mm,
For
y-
example, when you configure ISIS between the two router, for
yes,
example, if there is one XR router and another site, another XR router,
yes.
when we configure tag one VLAN with the port number for the logical interface. Can you please just me clarify this?
That is more of a syntax issue because that's how Nokia is configured. Uh, you need to configure the logical interface. Once you've configured that interface XXXX, you need to, same way, you need to give it a description and then you are defining the port. The port now, the physical port is defined under the logical interface. And once you've defined that port, you can, for example, if you want to where is the pen? Like you have port, and then this port you can define even a link aggregation. You define a lag, and this lag maybe it's lag 10 colon the VLAN. Maybe VLAN is 1000. So this will be the VLAN. This will be the of course, this one can be either the link aggregation group or it can be the physical port that you want to be bind to that specific logical interface. So it's more of just a syntax difference between the two vendors. Maybe you can ping me separately and we can see how to if there is any challenge or any issue that needs further clarification. I'll be glad
Okay,
to
okay,
discuss with you further on that.
okay, okay. Thank you, Marty.
Okay, okay. So the second step we are
Hello, Martin.
yes, yes.
Martin, sorry. I
Can
want
you maybe
to.
maybe maybe you just allow me to finish this
Okay,
group, then
okay,
as I continue with the configuration you can be asking the questions again. Is that okay?
noted. Okay,
Okay, so for the
yes,
second
it's
part,
okay.
we are configuring IGP, ISIS on the UPE, SPE, and NPE. We've done the IGP lab also in our previous sessions. If you haven't uh, watched it or maybe you missed the session, you can still find it on our channel. So for the ISIS, we are using ISIS 100 as the aggregation ISIS, and then one thing to mention, you need to configure the network entity correctly. We normally suggest that you should also configure the sysname. It will help you to troubleshoot when you are troubleshooting the connection issues. You need to set the level and then you need to set the cost style. So we use the cost style wide because it allows us to configure the cost values flexibly. So on the NPE, same configuration. On the SPE, we have two processes. We have process 10 and process 100 because we have the access and the aggregation processes. So you need to configure them and ensure that you activate ISIS on the interfaces. This is how you go about activating ISIS on the interface. So same is done on the different nodes. And then we will verify the ISIS status and ensure that we are able to learn the ISIS routes. I hope that's clear. You can proceed to ask the question as I continue to do the configurations on the devices.
Yes, thanks. The concept is just to make clear
Yes,
the usage of one IP address. I don't know because if we go through the BTS,
yes,
we can see different technology with different addresses for
yes,
each technology, 2G address and so on. But when we are saying talking about to use the one IP address, in that case, the connection between the BTS and the UPE, for example, uh, how can we implement it since from
On the BTS.
yeah, the connection between, yes, the BTS and the UPA, for example, because on the BTS we have each technology with different addresses.
Yes.
And I want to know
Yes.
how we can proceed to have just one IP address on UPE side.
Okay, that's a very good question. So, of course, we cannot use, that's why even when you check on my design, I've designed different IP addresses for different services. And again, once, for example, for this topology, we have BTS1, we have BTS2. We cannot just use 10.160.10.0/29 for all the services. Remember, the BTS doesn't have the VRF capabilities unless they have another different technology which they can help to isolate these different services. For them, I believe it's just like a switch. So you need to have all these IPs so that you can be able to support these different services. But now when we come to BTS2, we can still use these same IPs. We can use them on UPE2 and BTS2. So we will need these different blocks for different technologies. On 2G, 3G, 4G, 5G, O&M, we will need them for this BTS communication to the other services. But the same IP address, we can use them to configure the services on BTS2. So we cannot use the same IP address like 10.160.10.0/29 for 2G. We use the same IP for 3G. We use the same IP for 4G unless the BTS supports service isolation also. If they have configured some kind of VRF, yes, we can now go ahead and isolate the services and use the same IP address. I think that's the question you're trying to ask, right?
Yes, I can. Okay. And
We cannot use the same IP address for the different services on the same UPE because it's connecting to the BTS unless the BTS supports the virtual routing and forwarding also, like the VPN instance. If they have a mechanism, then yes, we can use the same IP. But if they don't, then we cannot. But you see, for the CSG, once you bind a different VPN, you can use the same IP on the different sub-interfaces bind with different VPNs, right? Is it clear?
yes, Martin. We can go ahead. We can move on.
Okay.
Okay. Thanks.
Any other question?
Sorry, Martin.
Yes, yes,
It's Kenzan here.
yes.
I'm assuming the usage of the same IP address is only applicable if those BTSs are not going to the same controllers.
Yes. No. Yeah, actually, that is also another issue to look at because the controllers also will not be able to differentiate based on the RDs, right? Unless, so you are right. That's also another reason why we need to assign different IPs for different services. Unless the entire network supports virtual routing and forwarding, then we are allowed to use the overlapping IP address based on the network. But if that's not the case, then yes, we need to ensure that every service has a specific IP block to ensure that you don't have any conflict. Because the same way, who has mentioned that point? About the control isolating the services. I missed the name.
Kenzan.
Okay. Hey, yes, the same way Hensan has mentioned. Because remember, we need to have back like bidirectional communication from the BTS to the VPC. And this VPC may not be able to isolate the different IPs. So for him, the IP could be the same. You will just get one IP and it becomes a challenge unless there is a mechanism that this VPC and the BTS can isolate these different IPs then we can use the same addressing space. If not, even on many networks I've worked on, you normally assign a unique subnet for a given service. Thank you for that point.
So for the VPC to be able to differentiate between the IPs, it needs to have the understanding of route distinguishers.
Yes,
If
yes, yes.
so, we would have to make it a part of the MPLS core. So, is it considered a good practice to do so or followed globally?
I've never seen a VIP, especially these controllers. I've not seen any, because you see, for us, this VPC, it's just like a customer that we are connected to, right? For us, it's just like the customer edge device, the CE. So we don't bring it to be part of our MPLS network unless we have some specific customers which are also behind the VPC that requires some special isolation of their services. So I've not seen
Yes,
a
so
solution where we integrate the VPC to be part of our MPLS network. No.
VPC is also considered as a customer
Yes,
and
yes.
BTS is also considered as a customer.
Yes,
So
yes.
that's why we would have different IPs for different BTS.
Yes, yes. Okay. Anyone else with a question?
Sorry, Martin. Coming just on the same question.
Yes.
What I notice, I'm a field technician.
Yes. Yes.
Engineer in the MTN site.
Yes.
But what I'm noticing, on the BTS, we have many technologies, as we say,
Yes.
with different addresses.
Yes.
But on IPRAN site,
Yes.
I can just find maybe one VLAN, only one VLAN for all those services, 2G and until 5G. We have many VLAN, but on IPRAN, we can find only one VLAN.
No.
Uh, uh,
On
sorry?
IPRAN, we still, because remember, the aim is to isolate these services, right? If we have just one VLAN, we will not have a way to isolate those services. And if we have one VLAN, it means the same VLAN should be configured on the BTS, and the BTS, if you have different VLANs on the BTS, how will it communicate through this single VLAN? So that's why on the CSG we also configure same VLANs. If it's a service VLAN on the BTS, we extend it to the CSG so that we can have the gateway configured on the CSG for that specific VLAN, right?
Ah,
Yeah,
I
when we
can
go
see.
through it, you will,
No
I
problem,
think
no
it will
problem,
get
no
more
problem.
clear. Yes, yes.
Okay,
So
okay.
Hello,
we,
Martin.
yes, yes,
So we can likewise say that different services are like different customers. Like 2G is customer A, 3G is customer B, 4G
yes,
is
yes. We can
customer
also see it in that
C,
way.
something like that, right?
Yes, we can also see it from that angle. Because
Okay.
remember, on the ground, we have someone who is using 2G. We have someone who is using 3G. We have someone else who is connected to 5G, right?
Yes,
Yes.
agreed.
Yeah.
But so in this scenario, I don't think we will have a scenario where a 2G service want to talk to the other 2G service without going through controller. It must go through controller.
Yes,
So there's
yes.
no, yeah, okay,
It has to go through the controller.
okay,
Even if there is a handover from 2G, I mean from 3G to 2G or 4G to 3G, still you need to go through the controller that will be managing these sessions, right?
okay. Thank you.
Sorry, Martin. Can
Yes,
you come back on the topology, the second one,
this one.
where we are?
Yes,
Yes, yes, this one. Okay. You see, on the BTS, between the BTS and
yes,
UP1 example,
yes.
we can have we can respect the configuration. We can have the same VLAN on the UP1, UP1, but between UP1 and SP1, maybe you can aggregate those VLAN from UP1 to one VLAN between UP1 and SP1. I think this one is possible.
Yeah, but remember that one now it's not, the forwarding is not based on the VLAN because this one we just have, like you see, we have just configured the point to point, we've configured the necessary protocols, ISIS, BGP, MPLS. So now when traffic is coming from the BTS towards the VPC, the forwarding will be purely on MPLS, right? We have the MPLS tunnel that will be carrying these services. So yes, these services will be aggregated into just as single or I won't even say into a single VLAN because it's just a way of us trying to establish the connection to the BTS one, the services and the UPE. They are now purely in the MPLS backbone, and the forwarding will be based on the MPLS label switching on our MPLS backbone network. So yes, these different services or VLANs, we can view them as we've aggregated them now into one link, which is now a layer 3 link, or the back-to-back connection that is now carrying the different services between the UPE and the SPE. Because remember, even on the same setup, we can have the services from BTS2. They can still come to UPE2, they go to UPE1, to SPE1, to NPE1, and then to the controller, right? Yes?
Okay. Yes, 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 yes.
Okay.
Okay,
Okay,
no
allow
problem.
us
We can
to
move on.
verify
Mm.
the
So,
configuration for SIS. So we've configured SIS. We need to verify that our peering is up. So these are the commands you can use: display SIS peer, display the verbose, display SIS interface. You can check the LSDP. You can perform ping tests. So just a quick check. I will use the UPE, can display ISIS peer. You can see that we have two peering session. Display IP routing table, protocol ISIS. You can see that we have ISIS routes installed. We can try to ping the SP IPs. .2, definitely it won't go through. Anyone who can explain why it's not going through? We are pinging from UP1 to SP1. If I ping 1.1.3, I mean 1.1.3, you will realize that it's not going through. If I display the route, just terminate it. Display IP routing table. You can specify the destination. .3, you realize that we don't have the routes. Anyone who can quickly explain why we don't have the route to SP1?
Um,
So
hello,
I said,
Martin.
Yes, yes.
Yeah, it's because they are in different ISIS processes.
Okay. They are in different SIS processes. So how do we fix it?
By importing routes
Yes, so we need
from
to
one process to
perform,
the other.
yes, we need to perform some route import between the access and aggregation. Again, all these details, we already discussed them in our previous episode. So just a review of our previous session. Someone else had a question, but let me just explain the next step, then we can continue. So we verified that we have the IGP adjacent this app, we have the routes. So the next step is to now import routes between access and aggregation IGP process, and these are the commands that we'll be using. We are configuring some IP prefix. Remember, you don't import everything from one process to the other. No, you need to use some routing policies to control what is being imported between the two. So we have one IP prefix to import the aggregation loopbacks. We have another IP prefix to import the point-to-point and also the loopback IPs. from the access to aggregation. So we have one route policy. Please mute. Someone needs to mute. Thank you. And then we have another route policy to import aggregation loopbacks, so that, remember, at the end of the day, we'll be configuring BGP between the nodes, and we'll be using the loopback IPs. So you need to import the loopback IPs from aggregation to the access. So this is how we perform the route import. We've already covered these also in our previous sessions, so I will just go ahead to do the configurations. Someone had a question as I do the configurations on the SPE1. Yes, proceed to ask your question. Then I'll do the configuration on SPE2. So remember, you just need to ensure that you have the right prefixes. Here you can see that we are using the .4. Here we use .3 because .3 is the loopback IP for SPE1, .2 is the loopback IP for SPE2. So I'll copy these configurations based on SPE2, and we should be good to just verify that now when I go to UP1, if I display the IP routing table, you can see that we have this loopback. If I do a ping, now we are able to ping the loopback IPs. .4, I'm also able to ping the loopback IPs. So we have reachability or connectivity between the different nodes. Any question? So again, you can display SISPI, you can check the LSDB, you can check the routing table, you can check the SPF log, just to verify that everything is okay. Whenever you are doing configuration, it's always good to perform checks step by step. Don't wait until you've configured everything and then you have to start troubleshooting the IP address, you have to start troubleshooting OSPF or SIS. No. If you are doing a kind of deployment, it's good to test step by step so that you are clear wherever there could be an issue. So you can also perform ping test. We've done this. You can check the routing table. Number 4, you need to close the ISIS access ring. Remember that whenever we have rings, you need to do some ring closure between the two. So you have configured ISIS 10 from SPE1, UP1, UP2 to SPE2. So we need to do some ring closure between these two guys, the SPE1 and SPE2, so that we have ISIS 10 running between the two nodes also, just to ensure that we have a closed ring from SPE1 back to SPE1. So these are the configuration. We are configuring a sub interface. On that interface, the back-to-back interface between SPE1 and SPE2. We assign an IP address. We assign a slightly higher cost, because remember, we don't want traffic, normal traffic, to flow through the connection between the two nodes. We only need it to carry traffic in a scenario where we've lost the primary connection. For example, we've lost a connection between GE00, between UPE1 and SPE1. Now that link can come in and carry some traffic. So we configure a higher cost on that link. So I'll do this on SPE1. I hope we are good so far. Any question, you are allowed to interrupt and ask. I do this
Mr.
on
Martin,
SPE2. Yes.
Okay, just maybe you already explained about this, but this of having different process ID.
Yes.
So why is it? What benefit we get from having different process ID instead of keeping them in the same process ID?
Same process ID as in?
Like the ring between ring 1 and ring 2 in ISIs.
Yes.
Yeah. Why can't we just put them in the same process ID?
Anyone who can respond to that question? Guys have been so quiet today. why we have different process IDs configured for the aggregation and access.
Hello, yeah, good morning. Good afternoon.
Good afternoon.
Yeah, my name is Fabian.
Yes, Fabian.
Yeah, you have two rings, right?
Yes.
So for you to separate the two rings, and the other one is access, the other one is aggregation ring.
Yes.
For you to separate the two rings, at least for to separate it, you have to put one on the access ring on different ISIS process and the aggregation ring on different ISIS processes. So that is the standard how it is configured. If you put them in the same ISIS process, there's no way you can separate the services. So because now for the access ring, you can have more than one access ring, okay, being backhauled by aggregation ring of the same ISIS processes. So you put the access ring on the different ISIS processes so that you can use it to separate different different rings. You can have ring 1, ring 2, ring 3 being backhauled by one aggregation ring. Thank you.
Elisa, you've got it. I hope that's clear enough.
No, yes, the explanation is good, but I'm saying that if we keep them in the same, is that going to affect the performance of the network?
Yes, yes, it's always a best practice to
Yes,
isolate them
yes.
into. Yes, yes, just proceed.
Yeah, it will affect. It will affect, just like I said, you use it to use that two different processes to make a separation. If ring A, access ring A is having services, you'll be able to differentiate just like a VPN does. You understand? Just like keeping the way you configure two VPNs for different services. That is how you configure those processes for different rings. So it is just the same like you're separating, like in layer 2, you use VLANs to separate logically. Okay, in layer 3, you use VPNs. So in this in the IPRAN setup, you use those rings, okay, to separate the access layers. You can have 3 access layers, okay, connected to one aggregation layer. So what differentiates them is those ISIS processes. So that's what I'm saying.
Okay, so what I understand is the benefits of different processes just to identify them. It doesn't really give any profit in the network, like performance or something.
Yes, it adds to the performance and for easy for you to be able to manage your network. It adds to the performance of the network also. Because if you keep everything in one ring, there's no
Okay,
way you
what
can
performance?
and mind you sometimes, yeah, and mind you sometimes, like the VPN we are configuring now, at the access layer we put low end devices, and at the aggregation layer we put high end devices, the devices that have bigger capacities. So that is why we can send a default route from the UPS now to the CSGs.
So there are benefits, yes, it's helping to isolate the access rings into different processes, and it's also a good practice because remember, once you put them in the same process, then the LSDB will be huge, the message exchange will be many. So you need to, it's actually the same like you putting the entire network into OSPF area 0 kind of setup, which is not a best practice. So you need to use the different processes.
Martin,
Yes.
Okay,
maybe
okay.
let me
Thank
just
you.
say something also on top of this, because
Yes.
I think right now the topology we are looking at is very simplified and maybe does not bring out a good picture from a design perspective. When you
Yes.
look at it at scale, when a service provider network with
Yes.
giving services to several regions, and from the design we know that we are going to have the CSGs, the ASGs, and the RSGs. So we need it would be really what very bad design that all the regions, all the routers, to put everything in one domain. I think from operational standpoint, considering the fact that now the CSGs, RSGs, and the ASGs, they are different. What they have different capabilities in terms of the computing power and all that. We can't have them all in one domain to share the routes, right? So that segmentation really, if you look at it also from a scalability standpoint, it's very it becomes clear that you need to be able to
To
divide them
isolate
into
them.
those
Yes.
various domains. But the second part also from operational standpoint, if you're now troubleshooting and you have everything in one domain, it might be really difficult to isolate
Yes.
faults easily. So if you have like different regions, then the access rings and then the aggregation, you segment them, even managing it will be easy, from my perspective.
You, where were you? You were late
Hello,
again.
Martin. Hello.
I was on the road. I'm sorry, I joined late.
Okay, you're welcome. Thank you for joining.
Okay.
Yes, yes,
Now listen. Okay, so let's say I have a network that is not so big.
yes,
Maybe at most, if I'm scaling, let's say in future, I can't have more than 150 IPRAN routers.
yes,
All right. Now, and I'm looking at the future that we're beyond. I can't do more than that because that is the best.
yes,
Is it possible for me to, and in my scenario, I have two ASGs
yes,
and I have so many CSGs,
CSGs.
right?
Yes, yes,
And those CSGs, some are not connected directly to the ASGs,
yes.
but I am able to form rings, different rings. Is it possible for me to have all the rings from the ASG to, I mean, from the CSG, all the CSGs to the RSG in the same ISIS process? Is it a good solution? Or what would be the best solution? And what would be the need?
So, Martin,
Yes, yes, yes.
so you ask, is it possible? Yes, it's possible. But is it recommended? No. Is it advisable? No. Because, I mean, to be very terrible design, if you just read the design
That's a very
principles and
bad
follow it
design.
exactly.
There are some networks
Yeah.
in
So it's
Nigeria that are doing
possible.
that thing,
To answer your question,
specifically
it's
in
very
FL
possible.
network. It's a very bad design.
So
It's,
I think we first start by answering this question. Yes, it's possible, but
it's a very
depending
bad
Martin,
on
it's
the
a
design.
bad
design
no,
principle.
it's a bad design, but easy. But it's easy.
No, 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 it's not easy actually. When you start troubleshooting, if you are the
Ah, yeah,
network engineer, that's
exactly.
when you realize that, okay, let's have some
Let me
order. Let's have some order, guys. One by
so,
one.
so let me
Yes, yes,
okay,
Fabian.
let me also add more to the questions because what
Yes.
I'm trying to
Okay,
refer to
okay.
is this.
Fabian, you
You
give the
see,
dialect sometime?
okay, so you see, I have in this scenario that I'm picturing,
Yes,
let's say we only have just two ASGs, right?
yes,
Right? But I have so many, let's say I have like 50 CSG for now.
yes,
And I'm also looking at scalability, right?
yes,
Now, all these CSGs,
yes,
if they are connected directly to the ASGs or the CSGs, I believe maybe it might still be maybe possible for me to connect them to have one ISIS process. So I'm even not saying that I have some that those CSG are not even directly connected. They are connecting some rings
other
are not
CSGs.
forming with ASGs.
Yes,
Some rings are actually forming with even another CSG. You see, it's a bit complicated, but I'm just looking at the best solution. Now, we are talking about HOVPN. I know you still talk about HVPN, but I'm not saying what would be the best solution. Do we still kind of have that one in a single? Is it advisable to have them, or how do we? Because now, if I have a ring that is not directly connected to ASG, and I want to have it in a different ISIS process, that means probably some CSG will be kind of like a route reflector in the middle, or maybe kind of serving like ASG.
Yes,
If you get
yes.
my question.
I get your point. Actually, the same way Deron has mentioned, we are using a very simple topology, but when it comes to now really networking for a network with so many nodes, the architecture may change, the setup may change. You can have the access rings, you can have it in one process. Yes, that's okay also. It's applicable, it's okay, but when it comes to now the best practices, the best solution, you need to be able to isolate these rings, especially if you have a ring network, you need to be able to isolate them into different processes. It will help you as a network engineer in troubleshooting any connectivity issues that you have in a network. Even you will be able to tell how the traffic flow is going, because you can tell this traffic from this ring cannot use this route because we don't have this IGP process configured in this ring. So whenever there is an issue in the network, it's very easy to predict where is the issue. How do I solve? Where do I check? It's very fast and very quick. So it's
Okay, I
possible.
understand.
It's possible. It's
But
yes, you can do it, but not the best practice.
so if I have a ring that is not directly connected to the ASG, what would be the best solution to
You can
kind of do my
use,
route?
you can extend through a layer 2 VPN. You can create a layer 2 VPN and terminate it on the nearest SG.
Okay. So a L2 VPN between the ASG and the nearest
And the
CSG.
nearest CSG that is in that ring, then you can achieve that. You can isolate it into its own process. That's what we
So I'll
have
consider.
done on multiple occasions.
Okay.
Guys, I
Thank
know
you.
we have, yes, yeah. Maybe you allow me, just allow me to start configuring the next part, then we can.
Sorry, Martin. Sorry,
Yes,
Martin. As
yes,
we are talking about the ring, yes, I want just to you should to show me the on our topology,
yes.
the different ring that we have, access and aggregation.
So for the access ring, it's starting from the SP, UP, and SPE. But now the aggregation ring, it's bringing in the SPE and the NPE. So you see we have NPE, NPE, SPE, and SPE. They are forming an aggregation ring. This is an access ring from the SPE towards the UPE. You get
Okay,
it?
thanks.
Yeah,
Yes,
that's
yes.
just 1 minute. Let me do the configuration for part 5, then I'll come back to you for your question or
Yeah,
comment.
sure.
So for step 5, we are configuring MPLS and LDP on the UP, SP, and the NP. So remember, we are building BGP MPLS VPN, so we need to be able to configure MPLS in our MPLS backbone. We also need to enable LDP for the label distribution on the interface. And whenever you are doing this configuration, you need to ensure that you activate MPLS and MPLS LDP on all the interfaces that are taking part in MPLS forwarding. So the first thing you need to do is to configure the LSR ID. And I've mentioned that we are using the loopback IP of the node. So you need to configure the LSR ID first, then you can now activate MPLS globally and MPLS LDP. Then you can now go ahead and activate these two protocols on the interfaces. So same has been done for the different nodes from the NPE, SPE, and the UPE. So I will start configuring the MPLS as I take the comment from Yahya. Yes, proceed as I do the
Yeah,
configurations.
yeah. So if we use different rings, we use different process IDs or different areas, we have to either redistribute or do route leaking for maintaining the reachability. So to scale it, we would have to summarize the routes or use default route for maintaining reachability. So my question was that in case of summarization or using default routes, how would the MPLS labels generation be handled? Because normally MPLS uses exact match uh,
Yes.
for a route to generate the label. So in case of summary route, how would it be handled? Would it be using some kind of LDB extension? I guess it's RFC 5283 that uses longest prefix match for generating the labels. So we can use summary routes to generate labels as well. So my question is regarding how MPLS labels are handled if we use summary routes.
Yeah, I think you've given us the response. You've even quoted an RFC. Okay, I normally also read some RFCs, but yeah, it's not fun at all. But yeah, I believe because remember MPLS labels are assigned to a forwarding equivalent class, right? The FEC. So once you have this FEC in the routing table, the label will be assigned using LDP, and then we have the label installed in the routing table for the specific destination or the specific forwarding equivalent class that we need to forward the traffic to. So I believe there should be a way. Maybe I can also check on it, or I can do some simulations and try to see how that one happens in a real networking scenario that we have route summarization in place. Or if anyone has a different response.
Yes, that would be interesting. So if you happen to test it, do let us know of the
Yes,
results.
yes, yes. I'll definitely test it. Some of these things, because in a real, sometimes in a ISP network, of course, there is some kind of summarization, but you may not really go into detail. So, but from the lab, we are able at least to do these different kinds of simulation and learn some new things about networking. So yeah, I'll definitely take it up and I'll give you feedback once. You are in our WhatsApp group, right?
Yes, I've joined the WhatsApp group.
Okay, okay, okay. Yeah, we can continue talking about it from the WhatsApp group. So
Thank you.
I've completed the configuration for MPLS. How do you verify? You need to display, for example, MPLS LDP PI. You need to check on the MPLS LDP interfaces, LDP session. I'll just run one command, MPLS LDP PI. So display MPLS LDP session. You can see the sessions. You can display the LDP peer, you see the peering. So this one verify that our MPLS and LDP configurations are okay. Nothing much, we've already discussed about it. So I'll move to step 6. Let me explain step 6, and then if we have questions, we can still pick some few questions. So for step 6, we now need to configure the VPN instance. Very straightforward. You just need to give it a name. So we are configuring a 2G VPN. This is the name of the VPN instance or the VRF that we are configuring. And then the route distinguisher, I've already mentioned that we are using the loopback IP. So the route distinguisher, you use the loopback IP double colon a random number. So we've already gone through the data planning for this. And then we configure the VPN targets. So for the different VRFs on different nodes, of course, we need to do the configurations. So I'll go ahead and do these configurations for the VPN instances. But if you have a question, you are allowed to ask or comment as I finish the configuration for VPN instances. So what will be changing is only the RD. Remember the RT, you cannot change it unless you don't want the communication between different nodes to happen through that VRF. So you need to do proper planning for the route target and the RDs and ensure that the RDs and the RTs especially, because they will be used to control the route exchange between the different nodes. So for NPE2, same configurations, just changing the RD, the route distinguisher, using the loopback IP of the other node, which is NPE2. Any question? Any other point of clarification as we finish with
Yes,
this?
so,
Yes.
the RFC number I mentioned, I probably said RFC 5238. It's actually RFC 5283 if you happen to check.
Maybe you can just post it on the WhatsApp group. I will check it out. Once I'm done, I can
Yeah,
do
sure.
some reading about it.
Sure.
SP1. Just copy it again. Guys, you need to be reading RFCs. It's also a very good way of getting to know many details about the working principles of some of these protocols. Then SP2.
Hello, Mr. Martin.
Yes, yes, Lisa.
Okay. I just want to ask a question about the. You said we don't need to change uh, the root distinguisher. Sorry, the what root target. Is that correct, right?
Yes, yes.
Okay. The root target can be the same in the whole network. It's fine.
It depends. You see, the route targets are used to control the export and import of routes. So depending on the network setup, you need to do the proper planning of the route targets. If you want a node to be able to learn some routes from a given provider edge router, then you need to ensure that they have merging import and export RTs, right? If you don't, then you
Yeah.
will have route distribution issues. The PE may not
Okay.
accept the route because the route is not having the correct RTs.
Okay. Okay. Okay.
So for UPEs,
Thank you.
we've completed the configuration of the routing instance. You can display IPVPN instance. You can see the VPN that we've configured. You can display interfaces. We don't have any interfaces. We should be having verbals of the routing VPN instance. You can see the create date, uptime, the route distinguisher, the export, the import VPNs, the label policy, and many other details. So this one, of course, just a mention, not going deep into them, but you can see all these details once you do the lab from your end. So once we've done this, we are moving to step 7. Step 7, you need to establish MP-IB-BGP peering relationship between the UPs and SPs and between NPs and the SPs. So remember, it's a layered architecture. SPs are peering to NPs, the UPs are peering to the SPs. So still straightforward configurations. We've already covered BGP configurations, the design principles. So you can still check it out from our previous sessions. So I'll just go ahead and do the configurations for BGP so that we save on time. Any question on BGP configurations? Anything that I need to explain?
Okay. Well, Martins.
Yes.
So you this is HoVPN, right?
Yes.
So but I can see that in that configuration, you are making the ASG route reflector, right?
Actually, this command, I can do away with it.
Okay.
Yeah, I think this one came in when I was doing other simulations. But many times remember we will have many SPs or many SGs. So many times the NP or the RSG will be the route reflector for the ASGs, right? Because it has to send all the routes that it's learning from other SPEs. For example, you will not find us configuring BGP peering session between SP1 and SPE2. No, they will only peer to the NPEs. If you have multiple SPE, SPE3, SPE4, they will all be peering to the NPEs. So this one can still be the route reflector for the network if you don't have just specific nodes that are primarily used for the route reflection. So you can still go ahead
So
and configure it as the route reflector.
so are you saying that we still need either HoVPN or HVPN? We still need to configure one of the devices as maybe ASG or RSG as route reflector? Because I was thinking for the HoVPN, we
Yes.
don't do anything like route reflector, but if it's HVPN, we have the ASG as RAS reflector. Maybe you can clarify.
Remember, when we are talking about the HoVPN and HVPN, the focus is on the CSGs and the UPs, right? That's where we are controlling the number of routes that are going towards the
Yeah.
UPs. So in that scenario, of
Okay.
course, when you configure the RSG as the route reflector, it's a route reflector for the aggregation nodes, the other ASGs in the network. Or you can have multiple NPEs in the network also. And if you are able to set one device as the route reflector, why not? You should go ahead and implement route reflection. In this setup, it's a very simple topology, very simple setup, so you may not see the need of route reflector. But in a big network where you have maybe 100 SPEs or 100 SGs, then you see you still need the route reflector to come in and ensure that you don't have meshed BGP peering sessions. I hope it's clear.
So in that case, sorry.
I think it's clear, but you remember I engaged you. You asked me to engage you one-on-one because I simulated. You remember that we had the section. I simulated the HOVP and HVPN. So I was thinking based on your past video that I've watched, because I didn't see you put making ASG as route reflector.
Yes,
So I
yes.
think that was I couldn't ping for the until I make the ASG as route reflector. I could not ping from the UP. I know I couldn't ping. I think the loopback of the MP, something like that. I couldn't learn the route. Rather, I couldn't learn the route from the NP on the UPs, something like that. If you remember, we had one
But remember the
session.
UP is using, yes, yes, I remember. The UP is using a default route. So the route from the NPE should not be propagated towards the UP. It should just use the default route that will be propagated from the SPE. But again, let's see how this one will, maybe it will fail to ping also. Who knows?
Okay, let's see.
So I've done the BGP configurations. We can do verification. The commands to verify are listed down here. You can display BGP VPN before all peer. You can display BGP VPN before all peer and do the verbose of it. You can just specify the specific peer that you want to check. That is allowed. So on SP1, if I display BGP VPN before all peer, you can see that we have these sessions coming up. We have 4 sessions, 2 to the UPE, 2 to the NPE. On any other node, we also expect to have the sessions up. So that is it for the BGP configurations. The next stage is to now configure service loopbacks on NPEs. So we need to configure some service loopbacks on the. Remember, we need to do some. In this setup, we need to configure some default route on the on the on the SPEs. So for us to be able to achieve that, we need to have or some service simulation interfaces on the NPE. So we are just configuring service interfaces, loopbacks on the NPEs, and then we are importing them into BGP. This one can also help us to test the connectivity between the different nodes. Are we able to propagate the routes from the NPE towards the SPE? And when these routes are the SPE, are we able to propagate these routes towards the UPE in this case? So these are the configuration, just same. You configure loopback interface, you bind a VPN instance, and then you go ahead and import the direct route. So when we are importing direct routes, we are importing those specific prefixes that are within the given VPN. So these are the configuration that we need to apply on the NPEs. So I'll just apply it and then we can move to the next stage and we can continue with the discussions. So I can do the same on NPE2, similar configurations, so that we have a default gateway that for the services from the SPEs. Once we've done that, we can also display the IP routing table. We can check the BGP VPN v4 routing table. We can check the VPN instance. We can check the received and advertised routes. All these commands are commands that you can use when you are doing your troubleshooting. So when I check on the SPE, if I were now to display IP or just display BGP VPN v4 all routing table, you realize that we have the prefixes that we have configured on the NPE, they are now being propagated towards the SPE. But when you check on the UPE, display BGP VPN v4 all routing table, you don't expect any routes. Remember, we have the split horizon that is in place. If you get a route from an IBGP peer, you don't advertise it to another IBGP peer. So that is the case. So we move to the next stage. Now, to the next stage, this is where we are now implementing the HoVPN. It's very straightforward, very easy actually. First, we need to have some default route on the SPEs. So remember, these prefixes, we've configured them on the NPE or the RSG in this network. So we are just telling the SPE that if you get a route that you don't know, just forward that traffic to the RSG. The RSG will handle it because it has, of course, it will have the entire routing table, and even the specifics will be coming into the SPE. But again, in case we have any traffic that is coming in and the SPE doesn't know where to forward it, just forward it to the RSG. So we do these configurations, and then this is the interesting part of HoVPN. So we need, remember, we are trying to make the SPE to advertise the default route to the UPE. So we need to specify for these different VPNs, advertise default route. Default route originate VPN instance, 3G VPN, 4G VPN, for all the VPN instances that we have. This is another implementation. You can use route policies to achieve this also, and you should be able to achieve it. So these are the configuration that we need to make. And remember, the UPE, we need to configure it as the UPE. I will omit this command and then we will see. If you don't configure it as a UPE, remember the UPE will also be originating some routes, right? And those routes need to be forwarded to the RSG. So if you don't configure it as a UPE, then this device is taken as a normal IBGP peer, and the routes will not be propagated because remember they are IBGP routes, so they will not be propagated toward the RSG because the ASG and the RSG, they are also in the same AS number. So we end up having the split horizon coming in and the routes will not be propagated towards the RSG. So we will see it in application. Let me just configure these commands and then we can move to the next stage of verification. Of course, the more we do the remaining steps, the more it should be clear to you how and what we're trying to achieve. So I need to configure this as the UP. We advertise default route on SPE2. We do the same under the BGP, different VPNs. Now, when we check
So
on the...
that means,
Yes,
hello,
yes.
Martin. That means UP is like a command that is allowed or that is understandable by the SP under the
Yes.
okay.
It knows when you specify this device at the UPE, then this is the kind of treatment I should give to the routes that I'm getting from this device.
That means you can specify whether it's NP as well, or even SP on another node.
We can try to specify.
Okay.
So if I run now display IP routing table VPN instance, remember we have the VPN instance to GVPN, you can see that we already have a default route. If we do 3G VPN, we should also have a default route for 3G. Same to 4G, we should have a default route for the same. So now we have propagated the routes, the default route from SPE to the UPE. You wanted to, let me see, on the SPE, display these to see the configurations. If I run peer maybe 1.1.1, and then you see we only have the UPE, so you can only specify the UPE. You cannot specify the NPE.
Oh,
Yes.
okay. Okay.
We will see it when we do the service configuration. So the 10th step is to now configure the services on the UPEs. Remember, we are configuring the sub interfaces using the correct VLANs, using the correct IP address that we've assigned, and we are also binding the VPNs. So you need to pay attention to the VLAN, to the VPN, and also to the gateway IP that will be used as the gateway IP from the BTS end. So we do the same for the different services, 4G, 3G, 5G, and O&M. I hope this is straightforward and clear. If you check on the SPE again, you will realize that if I display IP routing table, VPN instance to GVPN, you see we only have the static route that we've configured towards the RSG. We also have the loopback IP that we configured on the RSG. Those are the two routes that we have. Once we configure the BTS facing interface, we also expect to be getting these prefixes in our routing table. So that is something that you need to pay attention to.
Hello,
And
man.
this, yes,
The
yes.
screen is not visible.
You're not able to see my screen?
Me, I'm able to see it.
Check your network. Check your network. Maybe you don't have the good internet signal.
Maybe, yeah, because I've been sharing my screen all along. Okay, if you are able to see it, that's okay. So these are the service configurations. So I'll just copy these. Same on UPE2, we are just changing the IP addresses. So for the BTS2, so I'll start by configuring BTS1. We are just configuring the interface facing the BTS. So that is it. On the next part, I need to configure these UPE2. UPE2 facing the BTS2 system, and then we do the configurations. If I display IP interface brief, I expect to get those prefixes. You can see these prefixes, they are there. If I display IP routing table, VPN instance to GVPN, we have the direct route that we've configured. They are available in our routing table for the different loopbacks that we have on the UPE. Of course, we have the block, and then we have the local IP, the subnet, and then the local IP. When I check on the SPE display IP routing table, we don't have those routes. Anyone who can guide us how to check this? Why are we not getting the prefixes that we have here? They should be propagated towards the SPE. What could be the issue? Or what do we need to do? Yes. How do we ensure that the routes from the UPE are available on the SPE? Anyone who can give it a try? Guys, you are still there? Or you've left?
Yes, we are here. So I think so. We already configure the ESG to be route reflector, right?
No. Remember, we are looking at, we have configured these prefixes on the UPE, right? These
Yes.
prefixes are not available on the SPE. This UPE has not
Yes.
sent the routes to the SPE. That's what we are looking at. Why? Why the
Looking at.
UPE has not sent the routes to the SPE? Anyone? Anyone who can?
Martin, where did we originate the default route from?
We
Which
originate the
config?
default route from SPE towards the UPE, which is already
From
available
SP.
on the. Yes, yes. So if I display
Okay.
IP routing table VPN instance to G, you get that you have the default route and then you have the directly connected prefixes. But when you check on the SPE, you don't have the routes. 10.60. something. How do we go about it?
That's the current routing table of the SPE.
Yes, yes. How do we go about it? Yes, 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 yes.
Have we imported the static route into the VPN instance under the BGP?
Where exactly? On which device?
Under the IPv, yeah, on the UP. I mean, yeah, on the UP, when you display the BGP,
Is it
display
is it on the UP or
configuration.
on the SP?
UPE, I think.
These are the BGP
Okay,
configurations on the UP.
so we need to
On the
go
UPE.
inside. We need to configure IPv4 family, VPN v4, each of the VPN instance, and import static and direct, or import direct.
Okay.
Then we go. Yeah.
So yeah, that's true. This is the next. Where was it? This will be the next step. Uh, step 13, step 12. But let me first configure the BTS. So on the BTS, we are also configuring the point-to-point. So remember, on the BTS, we've assigned the point-to-point IP. So we need to configure .2 on the that VLAN that we've configured. In this sense, I've just simulated using a router. So you may not see the VLANs but yeah, we are using the same configurations. We configure the point-to-point. So I'll just do these configurations. .1 on the other end of the CSG and then .2 on the BTS. So I need to configure this device and do the same for BTS. This one should be BTS2. So I'll do similar configurations using the correct IP addresses on BTS2. Once we've done this configuration, we can even test the point-to-point. Are we able to ping the point-to-point? 10.164. 10.9. This was the other. So you can see that we are able to ping the point-to-point IP from the BTS towards the UPE. So now we can go back and fix the issue. So for us to be able to have the routes propagated, we need to import the routes. Remember, BGP will not have the routes unless you do manual import of the routes. You can either use the network command or you can do the import. For this case, we are just importing the static or direct. If you have static, if you have direct, you can import both of them. If you just have direct, you can just import direct. It's also okay. So once I do this, I paste it and then actually we should be on the UP. So on the UPs, we need to do the configuration for importing the direct routes, both UPs. Now, if I check on the SPE, I should be having display IP routing table, VPN instance to G. You can see that we have the route. So we have the routes here. If we check on the NP display IP routing table, VPN instance, to GVPN, you can see that we are also getting the prefixes from there. So this is where that command of UPE comes in. If we remove the command UPE from this device, from the SPE, BGP 65008, IPv4 family, VPN v4, and then I display this, and I will undo the command of 1.1.1.5 UPE. Peer, I need the peer command, undo peer 1.1.1.5 UPE. Then we check the routes on this NPE. It will take some time. It will take some time to edge off, but yeah, we can just continue and then I will recheck. So we've configured the VPN instance. We have imported the routes. Now on step 13, that's where we start configuring the services on NPE towards the VPC. So remember, we are using these IPs for the point-to-point configurations. You just need to bind the correct VPN instance and ensure that you've configured the correct IP address. So still same symbol configuration. We've mentioned that for OSPF, we are using OSPF to do the communication from the NPE towards the controller. So you need to configure OSPF. Very straightforward. You just configure OSPF process, the router ID, and then you specify the network that you want to be advertised and the area. And another thing that we need to do is also to import OSPF to BGP. You can use a prefix. You can use a route policy. That will be the best practice when you are doing such configurations. So I hope this is very clear. I'll copy the configurations. On NP1. Once we are done, we'll verify that the OSPF peering is up, and we should move on to the next stage of configuration. So we've configured our first node. On the second, we still have other more configurations. Let me copy from here to SPF 50. This one should be SPF 50, and then we can complete the remaining configurations. So we have OSPF configured. We've imported it to BGP. On NPE2, we do the same. Copy the configurations. And then apply on NPE2. Any question? Any questions so far as I finish on the configurations?
So we separated each of the VRM by OSPF process, right?
Yes,
and
yes.
Then okay.
We have different OSPF process for different VPN instances. You can see that we have 10, we have 20, we have 30, and we specify the VPN instance when we are configuring that OSPF. So we are isolating them into different OSPF instances.
So okay. So in this case, are we going to do VRP? Because we have VPC connecting via switch to both.
In this lab, I'm not doing any VRRP, but of course, many times you can go ahead and do VRRP. It's applicable. But when you do VRRP, remember, you can just use VRRP and you don't need OSPF, right? Because now the negotiation should be just on the virtual IP between the two nodes.
Okay.
Okay, so for the core switch, we have this configuration. For the core switch, same configuration, symbol configuration. We are specifying the core switch 01 as the name. We are using this command. So if you haven't configured Huawei switches, this is how you create VLANs in batch, you use the VLAN batch command, and then you specify you're creating VLAN from 1000 to 1009. So you can use this command. You don't need to create VLAN, each individual VLAN at a time. No, you can use the VLAN batch command and you will be able to create multiple VLANs at once. So once we've done that, we are creating VLAN if interfaces. So we configure the VLAN ifs for different services. And then we also configure OSPF. So these are the OSPF configurations. Area, we're using the same process, 10, 20, 30, 40, and then 50. So
which are the 10.90.16.0 subnets?
This is now, you see, this is the VPC subnet. If you go back to the, let me show you in the topology in the slide. You see, on the VPC, we have these prefixes. These are the prefixes that are configured on the VPC side. 10.90.10.0/29 for 2G, 11.0 for 3G, and etc. for the other services. So we also need to propagate them to OSPF so that they are land on the NP, right?
Yes.
Yes, yes.
So let's say if this VPC is like a cloud having different VMs, can we use instead of using a physical switch, is it possible to create a virtual switch on the VM? Instead of using a physical switch like this scenario.
Yeah, of course. You can have the virtual switch.
Okay.
Right?
And it will communicate with the MPs.
Yes. You just need to, depending on the application, depending on the setup, you can use the virtual switch. In this scenario, I'm just using the physical switch because that's what I can use for now. I don't have the virtualized kind of setup.
Yeah, I understand. Just asking.
Okay. So we were on these OSPF configurations. I'll copy and we do the verifications. Today at least we've been able to use OSPF. We have been using ISIS forever. So you can see the OSPF peering relationships are coming up on the switch. We can verify on the NP. If I display, these are the commands that you can use to verify. We have different commands. OSPF peer, you can check the OSPF interface. And that should be enough to verify that you have OSPF adjacent this app. So I will go back to this NP1. If I display OSPF peer brief, we expect that we should be having one peer per instance. So you can see here we have OSPF 10, we have one peer, OSPF 20, 30, 40, and 50. We have a peer per session. On NP2, we do the same. Display OSPF peer brief. You see that we have a peer for OSPF 10. We don't have a peer for OSPF 20. We have one for OSPF 30, 40, and we don't have one for 50. So we need to check
Hello,
why
Martin.
Yes.
So the OSPF that we did is between the MP and the switch.
Yes. The switch which is representing
so between
our
the
VPC.
switch. Okay, the VPC here is not okay. The VPC between the VPC and the switch.
Yes.
We just pass VLAN.
Yeah, remember this is just a representation. But this one we are using a layer 3 switch, which is acting as the gateway for the VPC.
Okay.
Yes. I hope that's clear.
So between the VPC and the between the VPC and the switch, definitely just to do because that means you didn't log in to do anything on the VPC.
Yes.
in this case.
Yes. In this case, we are just not doing anything on the VPC. That is now that's not my domain, I will say. Yeah, but of course, the same way we are doing the routing, they need to do some default route configuration to the gateway that is configured on the core switch, right? Many times the
Okay.
default route should be able to, or we can do dynamic routing also. If they have the capability, we can still do dynamic routing between us. We can use OSPF still, we can use BGP, right? We can use static routes.
Okay.
So,
Okay. I was thinking you were going to do something of VPC because you represented the BTS too, and you at least you don't manage BTS, but you
yeah,
configure, you do some configuration.
yeah,
That
but
was
you
the
see,
reason why.
the core switch is still part of the VPC, so I've already simulated it here.
No issue.
Yeah, so what we need to check is why we have OSPF between. We have one OSPF on process 10, which is okay. On process 20, we don't have a peering. On 30, we have one. On 40, we have one. On 50. So we need to check why we don't have a peering on OSPF 20 and OSPF 50. I know that's where Deron comes in. How do we troubleshoot the OSPF adjacency between
Okay.
NPE2 and the switch?
I think for me, I can start from we display the current configuration of the OSPF on the core switch.
On the core switch, okay. So on the core switch, just quit display current configuration, OSPF. These are the configurations. So we don't have one in OSPF 20 and OSPF 50.
Okay, we can do the same thing on the NPE side.
NPE.
NPS.
Display current configuration, OSPF. These are the configurations.
On this other NPE. Okay.
We don't need the other NPE. The other NPE is okay.
Okay. So this is between.
Anyone else can also. Let me connect to power as you check. These are the configurations for the NPE. You've had a look at it.
What about the interface? Those interfaces that are facing the core switch from the MP, whether OSPF process enable or something. Yeah.
We are using the
Imagine
network
first do
command.
show OSPF,
That's
display
okay.
OSPF neighbors.
Just 1 second, let me connect to power. Just 1 minute. Okay, you wanted me to check something? I'm back.
Yes, first display OSPF neighbor we see.
On which device?
So we were troubleshooting NP2 and the switch, right?
Yes. So if I
Yeah,
display
display on
OSPF,
NP2.
peer brief. So the issue is we have one peer for 10. We don't have a peer for 20 and 50. For OSPF process 20 and 50, we don't have a peer.
Okay, what about OSPF? First, interfaces, first play. Is it there?
Display OSPF interface. We have brief. So for OSPF interface, we have for 10 we have this one. For 20 we don't have an OSPF interface. For 50 we have this interface.
50 we have which one?
This network, right? This network, and an IP address with
Mhm.
this.
Yes. So it's failing for 20 and 50.
Yes, yes. For 20 we don't have an interface.
Can you, okay.
These are the
Can
configurations.
you go to
Display current configuration, configuration OSPF. These are the configurations.
what about the other side now? Switch.
The switch. These are the configurations for SPF.
Martin, what have you done?
Can we display OSPF peer brief here too?
Okay,
Yeah, like
display
yeah,
OSPF
first display there and we see.
brief. So here we expect to have 2 peering per instance, right? For 10 we have it. For 20 we only have 1 to P1 and P1. For 30 we have the 2. For 40 we also have the 2. For 50 we only have 1.
What about the VLAN HIF configuration? What IP do we assign?
On which
Okay,
VLAN if?
from this course switch on VLAN 20.
VLAN 20 it's 1 this one.
I mean, well,
No, it will be
110.
no, let me see. Display IP interface
I
brief.
think we need to decide whether we start with 20 or 50, but if we go both at the same time.
You can start with 20. You can start with 20 because they are different.
So VLAN 20 is
So you see
which?
the first, these 1, 2, 3, 4, these are for the first router, and then we have this one for the second router. So VLAN 20 will be 1006. So if I display current configuration interface, VLAN if 1006, you have the IP address configured 172.16.16.13. The other side
This,
it's
okay, the other side is what?
172.16.16.12 because it's a
Okay, can you
point-to-point
ping?
IP.
Okay. Yeah, we can go to the other side and check the direct points.
Martin, before you go, just go back first. Just sorry,
The
1
switch.
second before you go. Yeah. Hold on there. It's 13. Can you show the configuration? That's the VLAN is 13. Can you show the current configuration, the OSPF config for 20?
For 20, okay. Display
Hmm.
current configuration, OSPF. We have OSPF 20 here. We've propagated 172.16.16.12.
Yeah, so the network state, when I'm just looking at the second command, 172.16.16.12, 14. Okay, you have a wildcard mask of
0001, which is /31.
Okay. All right, you can go to the other side where
NP2, okay.
You check the interface connected.
Display IP interface brief. This is 1006. We have the correct IP configured. We are able to ping, right?
Yes, we are able to ping. let's compare 1005, 1006. I don't know whether you added anything.
You want to compare the code, the configuration on the switch or on
Yeah,
the
on the sub interfaces. No, from the NP on the router. Yeah,
display
let's
current
compare the configuration
configuration
on.
interface gig 0/0/1.1005.1006.
You know, Martin, the challenge me I'm personally finding with this OSPF shoot is that we can't even. We need to probably run a command, and I first see the current state. There are like 5, 6 states, right? Down in it, Xstat and all that. We don't know where it's ending and what it's stopping in.
Yes. Actually, for
Is there some
20
command you're not running for
the
us, or?
problem is very simple, and the issue here is that you've configured OSPF, but you've used a wrong VPN instance.
Okay, 3G.
So this one should be 3G.
That's true.
So if I do OSPF 20 and do, no, I'm in BGP and do OSPF, I'll give you the solution so that we save on time. We don't sleep in the OSPF 20. So I remove that and then I can reconfigure the same with the correct VPN. So this one should be, where is it? This one. This one. Let me just copy and notepad. And then I change this one to 3G VPN. Copy and paste. So we expect the peering now should come up. Display OSPF peer brief. It's coming up. And we are good for OSPF 20. OSPF 50, anything else you feel we can check apart from, so that we can complete the remaining part of the lab?
We need to still follow the same process to check. Let's display the current configuration.
The
OSPF on
process
both.
was that we gave up and Martin had to rescue us. So
I would
we
think,
still the same process.
I would think, I was
For
hoping on point to
OSPF we
point.
have, yes. We have these configurations for OSPF 50.
Can we ping
what?
the point to point? We
So
ping the point to point.
if I display
So,
IP interface brief, the point to point should be .18. Ping 172.16.16.17.19, right?
19, yeah.
We are not
Okay.
able to ping
So let's check the other side.
the side of the switch.
Yes.
What should we check?
We check the IP that we configure on the switch side, on the switch
Display
interface.
IP
The line
interface
is 50.
brief. 1009 has been assigned IP of 19.
Okay, display CCO OSPF.
Display
Current
current
configuration.
configuration OSPF. VLAN 50, it's here.
So, okay.
The thing is working, the P2P.
No, that's what we are trying to fix. What else, guys?
Is the
Let's
issue
hack
between
it.
the MP and the core switch?
Yes, the NP and the core switch, yes.
Have we binded the VPN instance to the interface?
On the NPE or on the NPE?
Yeah, on the MPE.
I can display
Yeah.
current configuration interface gig 0/0/1.1009. These are the configuration. We have the O&M VPN bind. We have the IP address configured. Oh, actually, I need to ping using the VPN instance so that we confirm.
Okay, yeah, you need to ping.
O&M
Yeah.
VPN. This is 172.16.16.19. We cannot ping.
This is the P2P.
Yes.
Can you display current configuration OSPF again? Yeah.
I think first we troubleshoot the P2P at least.
I suspect the .1 queue.
Yeah,
The
is
dot
it
one queue
the
has
correct
been
link?
configured here 109.1.0.0.9.
Can you display current configuration VPN instance? Oh, I mean.
You've gone back to configuration VPN instance. Which one? You need the O&M. This is the O&M.
Yes. And it's the same O&M that you binded, O&M_VPN.
Yes.
So the interface.
What else? What else? What else? Quickly so that we...
Yeah. How about the .1 queue on the core switch?
On the core switch. Okay. On the core switch, the command, what do you want me to check?
Yeah, so display current configuration on the ONM interface.
Display current configuration interface. The interface facing NP2.
Yes.
0/0/.
Yes, for ONM.
Oh.
No, so on the core switch, are the IPs on a VLAN if interface or a
Yes,
sub
they are on the
interface?
VLAN if. Display IP interface brief. We have the VLANs with the IP addresses.
So the
So
status is up.
Yes.
On the trunk we are only passing from 100 to 1008. So
Yes.
1009 is not included.
Yeah, that is the issue. /2. So we need port trunk allow pass VLAN 100 to 1009. Let's try to ping from NP2. We are able to ping, and the OSPF is up. Thank you, thank you, thank you. So yeah, just small configuration issue that will eat your mind the whole day while you're trying to troubleshoot. Deron, you okay? You've muted. So that is it for this for this configuration part. Finally, we need to now simulate. Remember, we need to simulate some services on the core switch. So we need to run these commands, just configuring the gateway on the core switch, the network that we've advertised to OSPF. So I'll go to the core switch and configure the loopbacks. These are the loopbacks that we want to configure, and then now the final part is on the service test and troubleshooting. So we've configured those networks, we've advertised them to SPF. If I go to NP1 display IP routing table, VPN instance to GVPN, you can see that we are getting those networks on the NPE via OSPF. When I go to SPE display IP routing table, VPN instance to GVPN, we have 1090.10.1, 10. We have only these 1090.10.1 IBGP coming /32 coming from IBGP. And then we have the prefixes that are coming from the BTS, I mean from the BTS side 10.160.10.0. On the UP, we should be having the default route still, IP routing table, VPN instance to GVPN. You see the prefixes. I want to check on NP2. Display IP routing table, VPN instance to GVPN. You are getting 10.160.10.0, 10.160.10.8. So now we have the routes. We've configured all the routing protocol that we require. Our environment is ready for testing the connectivity. So on BTS 02, we should be able to ping the VPC IPs to ensure that we have communication from the BTS to the VPC. Let's try it out. If I display IP routing table, you see that we only have these prefixes. So what we can do is we can configure a default route pointing we'll just use 2G as an example. So it's IP route static, a default route pointing to, because you can always configure multiple static routes. The next hop should be the gateway IP, which is 10.160.10.9, the one that we've configured, 60.10.9. So that one will be our gateway. If I try to ping the gateway, I should be able to ping the gateway 10.160.10.9. I'm able to ping the gateway. But if I try to ping the VPC 10.90.10.1, you realize that we are not able to ping the VPC from the BTS. So we need to do some further troubleshooting and fix the issue, and then we'll have end-to-end communication all the way from the VPC to the BTS and vice versa. Something else you need to do, you also need to do ping tests. You need to test link redundancy, you need to test BGP redundancy, because remember we've configured BGP sessions between the UPE and the two SPEs. So it's always good to do some tests to ensure that you have connection and the connectivity is okay. So here on this switch, display IP routing table, we have the prefixes that we've configured, the direct prefixes which are coming in. I need to check on NP if I display current configuration, BGP. You see that on this router, we've imported the different OSPF processes. So that's why that route is able to be propagated from the NPE to the SPE, because we've imported OSPF to BGP, and then we have the routes. So for us to be able to communicate from the VPC to all the BTS, we also need to have a mechanism. We can import, an easy way, of course, it's to just import BGP to SPF. So if I do SPF 10 on this router, I can import route BGP, and then I should be able to advertise the BGP routes. So when I check on this guy and display the IP routing table, you expect that you should now start getting the external route that are being imported from OSPF to from BGP to SPF. So if I do a ping, you can see that now we can communicate from the BTS to the core switch, which is hosting the VPC services. And the services should flow from the BTS to the UP1, SPE to the NP, and then to the core switch, because that is the shortest path. Right? What if we lose this connection? If we lose this connection, so this is part of the service test. Whenever you're doing the integration, you need to do some service test. If I shut down interface gig 0/0/0, I shut down that interface. With the ring setup, we still expect the services to go through. But you realize that our services are not going through. Why?
We will not import BGP into OSPF on. Okay, I think we on um the other MP, right?
Yes. We are not able to ping from BTS01. We are not able to ping the VPC. We have one link that is down. We have redundant path. This traffic can flow all the way, right?
Yes.
Yes. So what could be the issue and how do we fix such an issue?
Let's try tracing and see where it drops.
We trace to assert 10.90.10.1. So it gets to the gateway correctly, no problem, and then it drops.
Can we do reverse trace from the other side?
The reverse trace from the
The
switch.
switch. Yes.
So you need to trace to 10.160.10.2. Getting to the 10.160.10.1 and then it falls.
No, this is 10 dot. We do to 10 or so.
No. We only have the gateway here. It's 10.1. The IP on the BTS is 10.2.
Yeah, that's on the BTS2 now, not
Yes.
BTS1. We are tracing to BTS2, not BTS1, right?
Yes, we are doing the test on BTS2.
So it should be 10.10.
Oh, 10 dot. Okay, let me see. Oh, I get you. 10.9, then 10.10. 10.160, 10.10. It's not going through.
So from we are it to be from BTS1 or BTS2?
From BTS2. We are checking on BTS2.
On BTS2.
Yeah.
So you can that we are expecting the traffic path to be just close
From
the
BTS2 to UP1 to UP2 first, then UP2. From
uh,
UP2 to UP1, then it can now, it's already back into the MPLS backbone. So it can use either available path depending on the cost, right?
yes. Can you check if UP1 has the routes?
Oh, the routes too?
Hmm.
The UP1 is a default route. We are doing
This is
HoVPN, so it has a default route.
on the default route.
Yes.
Does UP2 also have the default route?
Yes. Display IP routing table, VPN instance to GVPN. We have a default. It's the default route has disappeared. UP2 doesn't have a default route. Why?
Because
UP1.
of the link between is receiving default route. So it's supposed to receive two default route normally. So we're supposed to do maybe a kind of policy to make one default route received from SP1 to be, so it should be receiving two, one as um, primary and one as secondary. I think so.
Yeah, but it
So
can only
we
install one. It can only install one in the routing table, right? For example, if you check on these, if I display, let's use display BGP, VPN v4, all routing table. Then we check 0.0.0. You can confirm that we are getting two. We are getting two. One from, let me see, let me just expand it. So we are in 2GVPN, right? In
yes.
2GVPN, let me move up a little bit. Let me do this. Let me specify the VPN instance. All HoVPN instance, GVPN, table 0.0.0.0. So from this you can see that we are getting one from 1.1.1.3, another one from 1.1.4, and this one is not preferred for IGP calls. So we are getting the two. For example, on
Oh,
UP1 we are able to get the two.
okay.
And on UP2, if we don't have any default route at this moment, we cannot forward any routes.
Yes, yes.
So it should be getting a default route from UP1.
So why is it not getting? No. We cannot have a default route coming from UP1.
I mean, it should be from
SP1 and
SP1.
SP2.
It should be
Yes.
from SP1. So it's the peer up to
BGP.
SP1. Yes.
Display BGP VPN v4 all peer. The peer is in connect. Why did it go to in connect?
So we need to sort the peer. Can we
Okay.
check if the loopbacks
Dot
are
3.3.
reachable?
What changed here? Let me see. On this one, display IP routing table 1.1.1.6. We are getting it 1.1.1.3. Display IP routing table 1.1.1.6. We have the IP ping 1.1.1.6. We're not able to ping on UP1. Display current configuration interface loopback 0. And we have OSPF enable. Everything looks okay. Display ISIS peer. We have this peer to UP01, which is up. UP01 display ISIS peer. You have a peering to this guy UP1 and UP01 and UP02. We have an MPLS LDP session towards this node.
Yeah. How about the BGP configuration?
The BGP on UP1.
First, that ping is failing. Can you try with source? Just specify source.
I source from.
Just source from loopback destination to loopback.
So you need to
Between
ping
between
-a.
UP2 and SP2.
Yeah, but display IP routing table. We have 1.1 and 3.3. Okay. So you need me to ping -a the loopback IP of UP2. I ping 1.1.3.
Yes.
Not going through.
So if we don't have reachability,
Yes,
how?
that's what we're trying to fix.
So yeah, reachability, not BGP at this point.
Yes.
Hello, Martin.
Yes.
I think you need to check the configuration of the interface facing the UP2. From UP2 to UP1. Let's check if we have MPLS enabled on that.
Display current
Yes.
configuration interface gig
Just
0.0/1. We have MPLS LDP. We have it. This is on
check on
UP2.
check on all the
Okay, let's check now the LSP.
This
Let's
is
check
LSP.
From UP2.
We have MPLS. We have
TSNL.
MPLS LDP.
Check on all the relevant interface. Just double
Yeah,
confirm.
it's just on this interface, right? Or you want on UP1, you want towards, okay, we do
Mm-hmm.
0.
EP1 was SP.
And also on SP.
On SP, you want it towards?
I mean, just check interface configurations for.
Okay, for this interface, we have this interface.
Mm-hmm.
MPLS, this is 0 facing UPE, then 1 facing the SPE, 2 facing the NPE.
Okay.
No, this one will be fine. Since we are pinging from UP1, it means that the rest of the path has MPLS. But from
Yeah,
my
because
side,
if
I want to
we
check if we have LSP from UP2.
from UPE2,
Yes. Can you check the LSP?
display MPLS, LDP, LSP. So when we disable this interface, the BGP goes down. When we enable it, the BGP comes up. So if we were to ping again, let me need to cancel. When we ping, that is going through. Whenever we shut down this interface, there is an issue. This router is
Yeah, then
detecting.
the problem is on the forwarding because the control plane is fine. We are seeing the route on the routing table, right?
Yes, yes.
But there is no forwarding.
Anything else that we need to check? We can also
For
try
my
with
job,
this one.
the
If
issue is
we
in the. Mhm.
if we shut down this, I need to first configure default route on this guy.
Before doing that, can you
Yeah.
check the BGP on UP2?
Yeah, the BGP should be up. Display
Just
BGP,
check.
VPN v4, all peer, all peer. Yeah, the BGP is established.
Oh, Martin, can you display the MPLS LDP session from UP2?
I display what?
MPLS LDP session or
MPLS LDP session all. Yeah, we only have 2 sessions, right?
okay, let's now shut down the interface 000.
Shut it down. And then
Okay, then reset the LSP, the session.
take some time to time out. Yes, has expired. So we have only 1 session towards UP1.
Let's check on the
Is it
IBGP.
possible to try to ping the LSP and then trace?
Yes, yes. One person at a time, please.
Confirm, check ISIS configurations for the 3 nodes, UP2, UP1, and SP1.
The ISIS, it's up. Display ISIS peer.
I mean,
Have ISIS, display current configuration. Configuration ISIS. You have a peering session that is, so you have, these are the configurations for the ISIS. If we go to UP1, display ISIS peer, you have a session with UP1, SP1 and UP2. If I display current configuration, configuration ISIS, you have these configurations. On SP, display current configuration, configuration ISIS.
it's okay.
It's
It's okay.
okay. Then if I display
Hold on.
ISIS peer,
Hold on. Hold on. Can you scroll back? Oh.
To which?
What? On this same node. On this same node. Just scroll up.
Yes.
Import route costs.
Okay. Okay. No, no share. Okay.
Anyone else? Anyone else? Even me, I don't know the reason actually.
Yes, Max, can
Yeah.
you find the BGP configuration from SP1?
BGP for SP1. Okay. Display current configuration. Configuration BGP. We start from top.
No, from the family VPN v4.
Family VPN v4. Okay.
This is which device? SP1.
This is SP1. Yes.
What is the IP of UP2?
It is
UP2.1.1.1.6.
and SP1 is 10.1.1.3.
So
Yes.
it doesn't have next stop local. Deploy
Uh,
to 1.1.1.1.5.
No, that
All
should
right.
not be
an issue.
an issue. Yeah, because we need to. That one can only come in the when the BGP is up, but we not having like communication. Then we can now check on the next top local.
But the configuration here, you enable UP function on 6.6, but it's not on the 5. What is this difference?
BGP 65008
Okay.
IPv4 family VPN v4 PIA 1.1.1.5 UP. But still, we don't have the BGP app. Display BGP VPN v4 all PIA. We don't have the BGP sessions up once we shut down this interface between the two.
Okay. Okay. Can you check BGP error on UP2 and SP1? Just check.
Display BGP error. We don't have any errors on UP
I
SP1.
think the problem should be on
check on SP1.
iOS on the SP1. Let's check the routing table if we are receiving this IP.
Yeah, on UP
SP1.
on SP
Yes.
display
The
IP
IP of
routing table
UP2.
10.1.1.6.
1.1.1.6. Yeah, we have the IP.
Yes. Can you try to ping the next hop?
Next hop is
Just ping the next hop.
10 to 50 10.1. 10 to 50 10.1.
Which node is it?
It's pointing to this node.
Aye, that is why.
But why will it point to this node? How is it learning it from this node instead of pointing to this? Because you see, this link is down, right? It's not being propagated, it's not being used in SPF calculation. So why is it pointing to this node and not here? Because it should be coming from this side, right?
Yes. Have you adjusted the cost for SIS?
Huh? Yes, someone
Yes,
is.
there is suboptimal routing.
Yes, yeah, there is some an optimal routing issue. So, guys, quickly, let's close on this today. Yeah, because definitely it should not be pointing to this node. If we check,
When we
let's check on this
imported
node. Display IP routing table 1.1.1.6 10 to 50 10.12. It's pointing to,
So it's a loop.
yeah, there is a loop happening. To quickly, let me just interface gig 0/0/ what /1.10, shut down that back-to-back connection, and then I do what? Display the IP routing table.
The BGP is up.
So it's pointing to the correct interface. If we check on this node, if we try to ping, we don't need ping address, will take time. We are able to ping without any problem. So yeah, when you are maintaining a network, you expect to have loop issues. That is the learning point. So yeah, we need to establish why there is a loop. That one, I think we may go until the night before we fix that. So, but when you do, another thing I just wanted to show you is, remember this is a VPN. So when we do the ping, we expect to, I'm just doing a packet capture. We expect to have the different layers of labels. So I'll do ICMP, and then I do my ping. We expect that we should be having the two layers of label, the outer and the inner layer label. So yeah, just a mention of that. So yeah, anything else that we need to test? Maybe BGP redundancy. You can bring down one BGP peer and test the other. Those are just some basic check that we do on this NPE. One another thing, you can display ARP to ensure that you are able to learn the BTS MAC addresses. You can see that, for example, the 2G that we've tested, we are able to learn the MAC address from the BTS side. And that one confirms that, yes, we are doing good on that part. Yeah, I think we've taken more time than expected, but yeah, I will open the floor for questions so that we answer
So
some few
this,
questions.
hello Martins.
Yes,
Now you disable the sub interface that you used to close the ring, right?
yes,
That was what fixed the issue.
they're causing the loop,
So
yes.
so what? So if I do this like a temporary measure now, what? How is my network? Is
Yeah,
it what would be the challenge? Let's say I that's what I can do, and the network is still running, the live network, and I'm still troubleshooting. So what's the is my network exposed to something, or
yes,
is
yes,
it?
you see the loop will not allow the communication. You see, once we have the loop, it was failing, right? We don't have communication from the BTS towards the VPC. So the services will be
Yeah,
down.
okay. But
Yeah.
presently, now that we disable it as a temporary measure, you
Yes.
mean everything is fine on this network
Everything is fine.
currently, right?
Yes, 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 yes.
So if you enable it again and try to if you enable
Troubleshoot.
the interface, although I know time has passed anyway, but
Yeah, I feel that one, when we are doing the lab, I hope we normally do the labs after this session. You can sit down and try to analyze it, do the
yes.
lab, and then, yeah, you can tell us the
Oh,
solution.
all right, no
Because
issue.
I know that one, it will take time if we start to troubleshoot, and I
Yes,
don't want to just tell you this is the issue. No, I feel that one can be the homework for today, right?
yes,
Yeah, when you
yes,
are
yes,
doing the
that's
lab,
fine.
you can try to establish why are we having the loop between the two. Even me,
Okay,
I'll give you the solution later. But
okay,
once you do the lab
I
and
think
prove
we
it,
need to
yes?
solve the issue with route filtering.
Yeah, you can fix it only then we can. I won't fix it right now, but yeah, on your own, if you fix it with the route filtering, the then you should be able to fix the issue, and then you can give us the feedback, Oscar. Okay, any other question, guys? I think it has been a very long session, and I appreciate your patience in staying into the session until we've come to the end. The issue of having the troubleshooting point is to just make it clear that, yeah, it's never that smooth. It's never that straightforward that you configure and then everything comes up, everyone is happy, they are browsing, and then we wait to integrate or configure the next site. No, you will have so many issues when you are doing new integration, when you are configuring these services, and you need to be able to troubleshoot and fix the issues faster because the customer is waiting to go online. So it's never that straightforward, but you can always take time and you can always try to understand deeper what could be the issue. Any questions before we close for today? It has been a very nice session. Any question or comments or clarification that you need? Yes, yes, yes. We can't hear you, Saravanan. You are unmuted, but we can't hear you. We can't hear you still. You can post on the chat. Maybe you can just post the question on the chat and then we will respond. Anyone else with a question? Question, a comment, anything that we need to explain before we end the session? It's already 3 hours of labbing.
Okay, let's say I have some sites that have not been able to deploy CSGs.
Yes.
Right? So I don't have a direct connection to the BTS.
Yeah.
But the BTS sitting at a remote site have maybe microwave connection to one CSG and microwave connection to another CSG. There's no CSG physically located on the remote site. Can I use VRP in that scenario so that one remote connection to one CSG is serving as primary, while remote connection to the other CSG is serving as secondary? This scenario, the BTS is not connected to CSG. It's on a remote site, but it has two parts over the transmission link, whether
So
fiber or...
the VRP you are configuring toward the BTS or towards the microwave equipment?
No. So towards the BTS.
Yeah, if the BTS allows you to do such configuration, it's very okay. If it allows you to configure VRP and be able to, because you see, for VRP you need to have a negotiation link for them to negotiate and then to notice when there is any issue, right?
Yes.
Yeah, so if your BTS is able to support such functionality, you can actually do that and have it primary backup kind of setup.
Okay.
Yes, Nicholas.
Yeah, let me just support, I mean, briefly on that aspect.
Yes.
When it comes to a remote BTS that does not have any CSG, what we normally do is this. We have a backbone microwave that is actually connected to a CSG that navigates services to those remote sites without those CSGs. So what happens there is we have a certain configuration on the microwave that take it to another microwave in that area, and then we have a transmission node there, and those transmission nodes are talking through VLANs, and those services are run through the VLANs, and when it gets to the transmission node at that site, the RAN, which is the BBU, will now take service from the transmission to the antennas and all of that. So this is how it normally works. You understand? Hello, can you hear me?
Yes, we can hear you.
So on a normal basis, on a transmission node, we have VLANs tag to the BBU of different services. Sometimes we even configure enterprise services on that transmission node, and once we have the enterprise node there will just do a physical connection, either fiber or LAN. So this is how it normally done. So the backbone takes the service to the remote site and through the microwave. And when it gets to the transmission node, we now patch it and do the configuration and just tag the VLAN towards that port going towards the BBU. So this is how it's normally done. And for the CSGs, they are normally at a particular site, and those sites are serving as the backbone. So we're having active and redundant. So in case it goes down, we have something we call on the CSG like a BFD. We have an active and the secondary. So it's coming from two different locations in case the one leg goes down and it will take on the other BFD. So this is how it's normally done. All right.
So there won't be need for VRP. That's what you mean?
Yes. This is how it normally done. There's no need for VRP.
Okay,
It just
BFD.
deal with it just deal with VLAN tagging.
Okay.
There are many ways of implementing redundant in the network. It all depends on the exact network setup that you have in your network. But there are multiple ways in which you can implement VRRP. I mean redundancy. If VRRP works well for you, depending on your setup, you can go ahead and do VRRP. If you have a unique setup, you can still use a different way to ensure that you have redundant connections.
Sure.
I don't have a simulator for you guys to practice Nokia router. I see Sravanan is asking me to share a simulator for Nokia. That one I don't have any that I can share for the lab simulations, especially for this IPRAN setup.
Now, I think the team can use what is called EVNG.
Yes, EVNG
If you
should
want to
be,
simulate
yes.
the Nokia.
Yes, you can go ahead and use EVNG. You just need to find the images and then you can go ahead and do the simulations. You asking for a link for EVNG? I think, yeah, that one should be available on Google. If you just search EVNG, this is, let me type it, EVNG. Then you should be able to get the application. You need VMware, and then you need the images for you to load on EVNG. Then you should be able to do the simulations. Last question or last comment before we close. Okay, guys, thank you for joining the session today, and I hope to see you soon again for the next lab simulation that we will be having in the coming days. It will be communicated, but again, we just stay tuned in for the upcoming sessions once they are ready. So I thank you again for taking your time to join the session and actively participating. I think it's a good learning for both of us. We exchange the knowledge, we share what we have in our networks, and yeah, it's very good. Yes, someone has a question, Leonard?
Yeah, Martin, can we have this lab that you just did for this session?
What do you mean by having the lab?
You like the simulation simulator file.
Yes,
The
I will share.
simulation.
The simulation file I will share in the group. Even the slides with the configurations I will share. The recording I will also share in the group.
Okay, thank you.
You're welcome. Okay, thank you guys, and yeah, have a good weekend.
Mr. Martin?
Yes, Elisa.
Yeah, thank you so much for your time.
Thank you. You're welcome. Thank you for your time too.
Yeah, but yeah, thank you. I know that I wasn't 100% engaging, but at least I get the picture of everything.
Yeah. You can catch up from the recording once you have time. You should be able to. If you have any any question, you can still reach out. Yes, Leonard, Sarvanan, I've shared my number on the chat.
Oh, thank you, Martin. It's been an informative lesson and afternoon. Thank you so much.
Thank you for joining. Thank you for your time too.
But Mr. Martin,
Yes,
Mr. Martin,
yes, yes.
I have one question, but I'll ask you in the through WhatsApp message.
No problem, no problem.
Thank you, thank you.
Okay, guys, thank you again. Thank you for joining. See
Thank
you
you.
in our next session.
Thank you. Thank you, Baba.
Bye.